So the next example we are going to make up a senior team of 8 students. Is this relevant to anybody in here at the moment? Okay. Well, actually, we're going to assume we've already got our senior team of 8 students, okay? And these students have very interesting names. They are named A, B, C, D, E, F, G, H. It's probably why they were chosen to be the senior students, because they had such convenient names. Now, what we need to do from our senior team, from them, we need to choose a head student and a deputy. And we want to know how many ways there are of doing this. So that's like the question.
I don't understand the question.
Okay, so for example, we are going to have a head student and a deputy student. We could have Emily as being head student, and we could have Callum as being deputy student. That's a possible choice.
So I thought you meant that they were like 2 different things and you have to...
No, we're just choosing the 2 people to be the lead people. Now, Callum might not like that. Callum might say, no, he wants to be the head student, and Emily could be the deputy student. So this is a scenario where the order matters again. And in lots of these questions, it's important, does the order matter or not? And later on, we'll see questions where the order does not matter. But here, the order does matter.
Would it just be 8 factorial over 6?
It may well be. Okay. So what we have got here then is we are choosing from 8 people. So that's the n. The n is the maximum number choosing from, if you like. Maximum number you can choose from. The how many people you want, that's the r. R is the number you are choosing. And it does fit perfectly this thing that we are doing. It will be 8p2, which is 8 factorial over 8 minus 2 factorial. Now, in the days when you didn't have calculators, it was really useful. You could write that out. That's 8 factorial over 6 factorial. So it's 8 times 7, but the 6 onwards just gets killed off. You can do that in your head, or you can do it in your calculator, or you can do it in your head and on the calculator in the exam and check you get the same answer both times. Which should be quite sensible. Okay, so that's permutations. What's the key thing about permutations? The order matters. Okay. So now we will come on to the other word, and the other word will be combinations. And this time we're going to choose 3 people from A, B, C, D, E, F, G. They've got really convenient names again. They're just parents of these people who named them like this just knew they would be useful in probability. So, choosing 3 people, we don't care this time though, we just want any 3 people. So this time we are going to say that the order does not matter. And order not matter is the key thing for combinations. And again, we are going for a subset of the people. So when you are choosing a subset of the people and the order does not matter, it's combination. So for example, if we had chosen A, B, C, then we would consider that exactly the same choice as BAC, CAB, and others. Okay, it's the same 3 people. Sometimes the order doesn't matter, you just need to choose 3 people. Now, will there be more ways of doing this or less ways of doing this? Yes, there will be less ways. There will be less ways than with permutations. That's working with the NPR thing. Now let's have a look in a minute. This ABC group, how many ways could I choose these three people? 6. Let's just see if we can get those down. 6 isn't very many. Yeah, okay. We could arrange those people there in 3 factorial, which is 6 ways. But for us now, they are all going to count as being the same. Yeah, so it's like last time, but we have to divide by 3 factorial. So if we had used the old system of permutations, we would have said that is, how many people are there altogether? 7. No. Previously, we would have said that 7 and then 7 take away 3. But what we're saying now is because those are all the same, we need to scale down by that. So I need to put 3 factorial in here. So this bit of red here is the new bit. So this is going to work out as being 7 factorial over 4 factorial over 3 factorial. Hang on a minute.
Yeah.
Okay? So that's 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm dividing it by 4 times 3 times 2 times 1 and also 3 times 2 times 1.
Wait, why are we trying to get back in that?
Down here, because I've count all these 6 ways now are going to be the same. Because then order doesn't matter. So that will cancel out with that. And I'm left with 7, 6, 5 and a 3, 2, 1 on the bottom. 3, 2, 1 cancels out with 6, because that's the same thing. So I'm left with 7 times by 5. I'm left with 35. I will come to your question in a minute. I promise. Okay? So what we have got here, we said this is a combination. So what we have here is n was, again, the number we could choose from. R is the number we will choose. The notation for this can be one of 2 things. It can either be NCR, like that, which is just like the P, except there's a C in there. Or it's also sometimes written down like this. A bit like a vector. N on the top, R below, in brackets. And the formula is n factorial divided by n minus r factorial r factorial. And that is the formula for combinations. And for combinations, order does not matter. Okay? So, if you sort of put that bit there in a red box, that is your sort of combination summary. I'm just going to pause the videoing at that point.